Hello, and welcome to Beacon Engineered Solutions Radiation Safety Training Classroom. Radiation refers to the emission or transmission of energy in the form of waves or particles through space or a material medium. It can occur naturally or be generated by various sources, including nuclear reactions, radioactive materials, electromagnetic processes, and high-energy particles. The naturally occurring radioactivity, commonly referred to as background, can vary greatly from one area of the world to another due to elevation and geographical properties. For instance, people in Denver, Colorado can receive 2 to 4 times more cosmic radiation than people in the Midwest. Likewise, some parts of South America and China can receive 10 to 20 times as much radiation from thorium and uranium found in the ground. Particulate radiation is small particles which have mass and in most cases an electric charge, which transfer energy from one point to another. Particles, by transferring their energy to atoms, can cause ionization, light, and heat. Therefore, they can be detected by using instruments such as ionization chambers, photomultiplier tubes, or Geiger counters. The more common particles are alpha, beta, neutron, proton, electron, and positron. Electromagnetic radiation waves are similar to radio, heat, sound, and microwaves. One difference between these is wavelength, with gamma and X-ray being of a much shorter wavelength. Gamma rays originate from the nucleus of the atom, whereas X-rays are a product of interactions with the outer shells of electrons of the atom. Ionization occurs when an orbital electron is dislodged from an atom and a positively charged atom is left behind. The dislodged electron is eventually captured in an orbit around another atom, and the original atom will capture another electron. This can result in chemical changes, especially in biological or organic materials. Radiation measurement. The energy imparted to matter by ionizing radiation per unit mass of irradiated material. The unit of absorbed dose is the rad, radiation absorbed dose. The original radiation dose unit used was the Roentgen and was defined as specified electrical charge produced in a volume of dry air by X-ray or gamma radiation. Since different types of radiation would produce different effects in tissue, the relative biological effectiveness, or RBE, was developed, and each type of radiation was tested to establish a quality factor, or QF number, used in calculations from rad to the Roentgen equivalent man, or REM. The amount of radiation exposure a person receives is defined under the governing regulations of the United States. Some of the agencies that establish these levels are the NRC, Nuclear Regulatory Commission, CDRH, Center for Devices and Radiological Health, as well as state departments of health and safety. These agencies have agreed on the following radiation exposure limits based on an occupational worker, 18 years or older, being exposed to these levels over their working lifetime and suffering no observable ill effects. People occupationally exposed to radiation may receive up to 5,000 mREM per year with no observable effects. When radiation damages living tissue, it can cause biological effects. These can be genetic or somatic effects. Genetic effects are caused by radiation that can alter genes and may cause birth defects in future generations. But it is very difficult to pinpoint exact causes of mutations or their original source. Genetic effects are the result of irradiation of the reproductive organs only. Somatic effects of radiation are those experienced by the individual, are the most obvious, and are of primary concern in radiation protection. These effects can be either acute or delayed, noticed immediately by sickness or death, or an increase in the probability that an individual may develop leukemia or cancer, and a shortening of the expected lifespan. Somatic effects severity controls. Living cells can repair themselves as soon as damage occurs. Therefore, the body can keep pace with a certain amount of radiation. A person in good physical health can recover from a certain radiation dose quicker than a person in poor health. The type of radiation and its penetration power, gamma and X-rays can penetrate all the way through the body, whereas beta particles and low energy radiation barely passes through the skin. Exposure time and total dose, a person who receives 500 R in one day has less than a 50% chance of living, whereas that same dose over a period of 2 months would leave a person with a 90% chance of total recovery. As low as reasonably achievable. This means that every reasonable effort shall be made to maintain radiation exposures as far below the dose limits as practical, taking into account the state of the technology, the economics of the improvement in relation to the benefits, and other socioeconomic considerations. If the radiation safety officer provides dosimetry to a worker, it shall be worn by the operator during X-ray equipment use and stored in an appropriate location when not in use. Time, distance, and shielding are vital components to radiation safety and should be kept in mind when working with the machines. Keeping in mind the federally allowable dosage for an occupational worker of 5,000 MR per year to the whole body, these tables are some examples of exposure doses and how distance and time factors into the equation. X-rays, which are energy and wavelengths much like light, are applicable to the inverse square law, which states the intensity, or measured dose, is proportional to 1 per R2, where R is distance. Radiation safety conclusion. Always practice radiation safety. If a local radiation exposure is suspected, terminate the X-ray equipment immediately and contact the radiation safety officer. If a radiation emergency occurs after regular working hours, contact the radiation safety officer. RSO 24-hour phone number 320-808-4874.